Hello and welcome to American Printing House Access Academy. We are glad to have you join us today for On the Road to Code 2, Code and Go Mouse. And I am going to turn it over to our very own Leslie Weilbacher. Leslie, next slide is yours.
Great, thank you very much, Leanne. Yes, so I am Leslie. I am the outreach specialist with APH for the Northwest region. Before I came here, not even a year ago, I was a TVI O&M for 6 years in a few different school districts. And now my focus is on assistive technology. But I should preface, I am not an expert in coding. I just have an interest in this. And I find it really fun and important for the field. And I will now introduce my co-presenter, Diane.
Thank you, Leslie. I'm Diane Brauner, and I split my time managing the Perkins Passive Technology website and working with app developers and collaborating on assistive technology projects. I have 25 years experience as an orientation mobility specialist, working primarily with preschool and school-age students. And I am like Leslie, I am not a programmer, but I am very interested in all of these computer science concepts and games like Code and Go Robot Mouse. Back to you, Leslie.
All right. I think we're going to talk about some objectives real fast. So our first objective is we will reinforce orientation concepts of directions, obstacle avoidance, route planning, and route planning with tactile graphics. 2, we'll build some vocabulary for coding concepts such as algorithm, which is putting commands in a sequence. Input, giving the computer a commands. Store, holding on to the information. And output, taking that information, that stored information, and producing an action. And 3, practice math skills of building mazes with the tactile graphics, finding coordinates, and creative problem solving. Other routes, creative problem solving, other routes. Sorry. And we have a quick touch base poll here.
So I have launched the poll. The question is, what is your comfort level with coding and coding concepts? Excited, but don't know where to start? Interested, but a little overwhelmed? Very comfortable and ready to go? Or not comfortable, but I want to support an interested student? Give that a moment to come in. Just getting an idea of where you feel you are at. And a majority of people have answered, so I'm going to end the poll and just share. 60% are excited but don't know where to start. And then 20% and 20% with very comfortable and not comfortable.
Well, this is perfect then. This is a great place to start if you're comfortable or not comfortable. This is the a Code and Go mouse is a great foundational learning skill that is not intimidating. So let's get into what is coding. So coding is a language that we invented to give computers information and commands. It is it's also logical ways of understanding things around us and problem solving. And kids learn that when they code something like Code and Go Robot Mouse, what they tell the mouse to do is exactly what that mouse does in that exact order. Now I have a picture on the screen here of block coding interface. And it's a white background with light gray grid lines, and then chunks of color blocks that fit together like puzzle pieces. And this is a very typical display of some coding apps that are meant for kids to start learning coding. Block coding is a very typical way of doing this, because it's a simplified way of using coding languages. Each block represents a piece of code. So coding for students who are visually impaired. Most coding apps for students are not accessible. There are instructions to read, there's animations. It's this block coding language that is visually appealing, but is very visual and spatial. And it's a drag and drop interface. So, and that can be very challenging to make it accessible. But we need the same opportunities for everyone. We need access to these learning opportunities, because coding can lead to so many different career paths and other opportunities. Coding and other forms of computer science is everywhere in our world these days. So what can using a programmable robot mouse teach? Problem solving, self-correcting errors, critical thinking, analytical thinking, if-then logic, working collaboratively with others, discussion and communication skills, calculating distance, and spatial concepts. And you might look at that list and go, really? That doesn't, how can you learn all of that from this cute little robot mouse? And we will dive deep into that in just a second. Because really, how does this cute little thing equal coding too? So the process of using this mouse is the same process you will use for coding. It's like block coding in that you press a button on his back, and that gives a string of code for a command. So let me describe this mouse real fast. This is a picture of the mouse on the screen. His nose, and this does look like a representation of a cute little mouse. His nose is towards the top of the screen. He has little eyes and little ears. And then on his back, he has several buttons. He has an action button that's red, a yellow, that's also a circle, a yellow circle button that's a clear button, and then he has 4 directional buttons facing the directions that they go. So there's a blue forward button that's pointing towards his nose, a purple right button, a yellow back button, and an orange left button. And in the center of those is a circle green button that's run. That's the go button to play the code. He has wheels, and when you turn him on, you get some fun sounds. So he's very engaging and cute, but every time you press a button, you get a block or a piece of code. So let's blast off from CodeQuest. I want to make sure that we draw a comparison and a distinction here. We talked about CodeQuest in part 1 of this series, but that doesn't mean that you do one before the other necessarily. Both of these are foundational skills. CodeQuest works on some things more than Code and Go Mouse does, but Code and Go Mouse is in some ways even more foundational and you can use with younger students. But I will let Diane talk a little bit about that.
Okay, so Code and Go Robot Colby is the name of the mouse. So we're going to talk about Colby versus CodeQuest. So CodeQuest is an app requiring some prerequisite tech skills and some basic mental mapping skills. The gameplay with CodeQuest is intended to be two-dimensional with your finger on the screen. When you go to Code and Go Mouse, it's intended to be hands-on with a robot, with the tactile manipulatives and a tactile game board. So Colby is 3D and is geared for preschoolers and young students. Now, one thing that I think is really interesting when Leslie said, which one comes first, Colby or CodeQuest? And it really depends on your student and your student's goals. So Leslie's going to explain in a minute about how Colby builds off of CodeQuest, but I want you to keep in mind that 3- and 4-year-olds can learn and enjoy unstructured play with Colby. And sometimes we, the teachers, we overlook the importance of free play. So I've used Code and Go Robot Mouse. I've used Colby with some 3-year-old and 4-year-old students. And one thing that I really found is that the preschoolers and these young students can explore and create simple play with the Code and Go Mouse. A 3-year-old can learn how to code the mouse to travel around his classroom or around the child's home. These young explorers prefer that free play time, just playing on the floor instead of the more structured activities on the grid. During the free play, the young student can be creative with his roots and he learns to trash or clear. And the little guys usually use the word trash. They learn to trash the previous code and when to keep that code and add on to the root. The child might like to build obstacles, such as stacking solo cups and then crashing Colby through it. During the free play, the students incidentally learn to problem solve and to discover things. Free play fully engages the very young students, and they'll stay tuned in for a really long time. So to learn a little bit more about some of the free play goals and how different preschoolers might use Code and Go Mouse, there's a post on Pasta Technology called Code and Go Robot Mouse. And that link is at the end of our presentation. Okay, Leslie, back to you.
Okay. So building off of CodeQuest a little bit here. Both of these work with directions. In CodeQuest, we had up, down, left, and right because we're on an iPad screen and it's, one plane. But with Colby, we get to say forward and back. Both can use a grid layout, but like Diane said, you can totally freeform with Colby. But both of them, you have to have the commands in the right order. You have to build a sequence of commands that makes sense. If you say, Colby go left, and he runs into a wall, you need to rethink that. You go, okay, Colby needs to go forward, maybe. Maybe there won't be a wall ahead of him. Both of them, you would press directional arrow buttons. Both of them have that tie to block coding of this represents the code for this action. But with Colby, you can create your own mazes. Now you're going from 2D to 3D. If you start with CodeQuest, sometimes it's easier to do the opposite. Sometimes it's easier to have a physical representation. of how something's going to work. And actually in the last slide, there was a picture of 3D printed materials that go with CodeQuest that you can add to it if that is a struggle with it. And that is a downloadable link on the webpage. But with Colby, you've got the 3D. It's out of the box 3D, and you can use him in all of the environments that you want to take him in. I wouldn't take him in the bathtub. This is a image of a level from CodeQuest, and this is a very obvious grid. There's some of the squares are blocked out as unbreakable walls. Some are walls you can blast through. You have an astronaut in the upper left-hand corner. He's always in the upper left-hand corner. But Colby might start anywhere in the maze. So I'm going to review some vocabulary from CodeQuest. First one is sequence, and that's putting steps in an order. And that is very important for our new vocabulary. And that sequence of putting steps in an order might look like first, second, third, last. Debug or debugging or problem solving, it's finding an error and fixing it. It didn't work. Why? How do we fix it? And loop, an action that is repeated. Now, with CodeQuest, there was a specific button that you can use to indicate a loop. The astronaut goes forward 4 times. You can do, I'm sorry, the astronaut doesn't go forward. The astronaut goes to the right 4 times. You can say right, loop 4 times. Colby, we don't really have the option to do that, but you certainly repeat commands. And it's like walking when you repeat the same action of moving your feet until you reach your destination. So let's meet Colby. So what is in the box? So we have Colby the mouse. I talked about him a little bit already, our blue cute little mouse. And I should add that his nose is a rounded piece on the front of him that is magnetized. So when you get the wedge of cheese, and it is a yellow wedge of cheese, complete with some indentions to look like holes to make it look like Swiss cheese. When he finds his cheese, his nose definitely magnetizes to that cheese. He grabs that cheese. There's green tiles, and those are to build the mat. And you can make them into a grid, and there's other shapes that you can make as well. There's purple walls to build the mazes. So those will wedge in between the tiles and stand up. And there's orange tunnels to add to the mazes, just to add another element, another obstacle to go through. You have small command cards to write the code. And these are 1 by 1 inch squares that have the arrows on them. You can take these and write out your code. You can lay them out in the order you think the code needs to be, the instructions, the steps that you think Colby needs to take, and then you can program them into his back. There's the maze layout cards, which are colorful pictures of how to build different mazes. They start out very, very simple and they get much more complex. And then we have tactile graphics of those maze layout cards. I should add at this point that this kit is actually something on the open market that we took and we made more accessible. Thought this is a great product, but it could be so much more usable for students who are blind or visually impaired if we added these tactile graphics, if we added Braille labels to those small coding cards. And that is what we did, including a Braille diagram of Colby and a key to describe the symbols we use in the tactile graphics. So some transferable skills we have with Colby. So, beyond coding, beyond the foundations of skills you will need to reach a career in coding, we have a couple of things. You can reinforce O&M skills with route planning. You can build confidence with math concepts of grids, rows and columns, reading tactile graphics, which is definitely something that needs to be practiced, and reading a map key. I know in social studies, that is a big thing that is focused on for a while. And this is a picture of my lovely intern's hands reading one of those tactile graphics. So let me talk about O&M skills really fast. Typically, we want the shortest path, but sometimes you need to change your direction. Maybe you want to swing by a coffee shop on the way instead of going straight there. You need to know how to read a map or tactile graphics. You need to understand the perspective of where you are in space. If you go there, but then you need to come back. So you need to be able to reverse things. Remembering steps and being able to give directions. And how does this work IRL or in real life? This is a picture of me when I was 19. I was on a study abroad in Berlin, Germany, and I have my first guide dog, Cammie, there with me, a little black lab girl. And I'm looking back over my shoulder, my backpack, because my friend just called my name, and I was like, what? But I'm standing in this interesting area. There's these large concrete rectangular pillars around me, but they're all at different heights. And I'm sort of in this path between them. And what this is a Denkmal. It was a Holocaust memorial that took up at least half a city block, if not the whole city block. And you passing it on the sidewalk, you just see these knee-high concrete blocks, and you're not really sure what it is, and you start to walk through the path, and they quickly the ground slopes down into a bowl, and these columns come up over your head, and the sounds of the city around you are dimmed, and the light comes through in different ways, and it's very disorienting. But it was a real life maze that I found myself in. A very moving memorial, and you can definitely feel that way when you're out and about. If you get turned around, you need those creative problem solving skills of how do I backtrack? How do I get out of this situation? So let's talk about some math concepts, and I'm going to let Diane jump in on that.
Okay, so this slide shows math concepts. What is a grid? We want to talk about rows from left to right, columns from top to bottom, finding the coordinates to place the tunnels, walls, actions, and cheese. Starting at 0, count the spaces up to and including the cheese. So on the screen, we have a picture of the activity card, and the activity card shows a maze. This one is a square maze. It shows the mouse in the bottom right-hand corner. The orange places on the maze are the 2 tunnels, And then the little purple lines are the areas where you can't go through. Also in the picture is a tactile graphic from APH that shows the same maze. So we can start by saying that the mouse is in the bottom right corner. For kids that are doing rows and columns, we can say that the mouse is in the 4th row and the 4th column, and that's the bottom right-hand corner. We can teach grids and rows and columns. And then when I think about my little guys, when I do Code and Go mouse with the little ones, they may not be quite ready for saying it's in row 2, column 3, that kind of information. But they're starting to get, you can introduce that row, go across the row is left to right, go in the column, it's top to bottom. And you can start introducing those concepts. This game with the robot, you can play the game without naming or using rows and column numbers. With CodeQuest, it is automatically announced every row and column. And so that's a big part of the game. You have to understand part of the rows and the columns for CodeQuest. But here you have the opportunity of using rows and columns and giving that number and providing it, or you can just start to introduce that. The kids don't have to be knowledgeable with rows and columns. Okay.
I am going to jump into some quick vocabulary, building off of sequence, debugging, and loop. We also have algorithm, which is a sequence of commands. So sequence is putting things in the right order, and an algorithm is taking that sequence of the commands in the right order. Input is the signals or instructions sent to the computer. So that's pressing those buttons on Colby's back. Or in some other examples with CodeQuest, you're pressing the button on the screen. Or when we get to Code Jumper, it could be attaching a pod. Store is saving information to use for a later time. So Colby doesn't immediately do the action when you press the button. He holds on to that action until you tell him to output it. And he will then take that stored information and produce it in data or an action, such as running the maze. For which would be the same with CodeQuest. You press go and the astronaut goes through the maze as well. With Code Jumper, which we'll talk about next month, the song will play or the story will play. So let's set up. We want to orient all the tiles the same way. That'll make putting them together a lot easier. If you have the smooth side, so each of these green tiles, there's 2 smooth sides, which you want on top and to the right, or sorry, to the left. And top and left, smooth, top and left. Then the other 2 sides, the right and bottom, have little hooks that face up. So this way, when you take a tile with the smooth side to the left and you put it on the hooked side of the first side tile, it just snaps into place very easily. And then you can add the next row with the top smooth side into the hooks of the first one on the bottom. You might want to just read one row at a time of the tactile graphics instead of trying to remember it all. You can practice locating different coordinates by going, oh, the mouse is on row 4, column 2. Oh, and the cheese is in row 4, column 1. You can use a tray or boxes to keep the pieces organized. I have a picture here of a long tray that has dividers in it. So all of the pieces are separated out. That just makes it a little easier to grab what you need. And we can now move on to some directional concepts, but we have a little video to show about putting those tiles together. And this is, again, my lovely intern, Tamaya, who is a high school student. Is that, yep.
One more.
One more, here you go.
Yep, on this row.
And making sure it's
Smoother than the top and the
and it goes right into the spot. Perfect.
oh,
There it goes. That took us a while to figure out. I got this kit. I opened it up. I thought, oh, this is easy to put together. I had to do some problem solving to just make sure, okay, you want to have all the tiles oriented the same way. And then I handed it to Maya. And once I explained that to her, then it was an easy thing. Diane, do you want to?
Sure. So one of the things, I always like to take these games and to expand them a little bit to whatever it is that I'm working with with my student. And one of the things that I see is that we often overlook creativity and drawing. And while this isn't exactly drawing, there's a lot of creativity when it comes to putting these grids together. Not every grid is 4x4. Some of them are like a path. Some of them have a hole in the middle. These tiles go together in different ways. What I found is that the students who are blind or low vision often don't have the opportunities to be creative or to draw their own path. So taking these tiles, they can create their own grid, their own shape, a road where it's just wherever it is that they want to go, and they can be creative. And again, it's not drawing per se, but it's the ability to be creative. So taking the tactile diagram and then building out that drawing, taking that activity card and making your grid or your drawing according to the activity card, adding in the maze part where you're putting in the walls, adding in the tunnels on the places that they're supposed to be and where Colby's supposed to start and where the cheese is supposed to end. That is really building, and it's something that the kids really enjoy doing. So don't forget to make this fun and give them the opportunity to create that maze, whether it's their own maze in a free play or giving a student the activity card, the tactile diagram of the maze, and having them complete that. And for some students, they want to make their own maze and then create their own tactile graphic to go along with it. So using like the APH Wheatley kit or the Sensational Blackboard, they can draw and make their own tactile image to go along with the maze that they created.
Great. And I love that idea, that idea of drawing with this. And then you get to work on those directional concepts,
Absolutely.
identifying those different directions, and again, working on perspective. Okay. So let's get coding here. So we're writing the directions for the mouse or Colby to get through the maze and find the cheese. That is our objective here. That is going to be the program we're going to write. Colby moves the length of one tile per press of the forward or back button. Pressing the left or right button turns Colby on the spot. He does not move forward when you press a right or left button. which is different from CodeQuest, where if you pressed left, he moved left. He didn't turn left. You can lightly touch the top of his back to follow him if you want through the maze. But I have another video here to show Tamaya working through some problems. And you don't see in the video that prior to this, Colby kept running into a wall and kept turning the wrong direction to get around the corner in this maze.
Forward.
You can move him as you do it too.
Okay.
Yeah, there you go.
Forward.
And then you want him to turn. Can you?
I think that's his left. I don't know.
That's
the arrow that
right.
faces
Yeah, you
it.
can feel the arrow. That
And
helps.
then forward.
All right. Yeah, there you go.
Then right.
There you go.
And
And
then forward.
good.
And then left.
Let's try it. Forward, right, forward, right,
There we go.
forward, and
Got it.
got it.
Well, actually, no, he didn't make it to the team.
Oh, what didn't he do?
He didn't go forward again.
Oh,
Forward. Okay. He did make it past the corner though.
yep. So that's progress. Right, forward, right, forward, left, forward.
Oh,
Yay!
I just spoke to Tamaya this morning, and she was saying that she is still very much enjoying playing with Colby. Okay, so how is this coding? Well, talking about our vocabulary words again, coding input, store, output. We figure out the root and we write down the order of steps in problem solving. That's our algorithm. We press the buttons, input. Colby holds on to that information, stores it until we press go and Colby runs the maze, outputting that information. So here's a sample of written code. We've been talking about block coding this whole time and pressing buttons. Here we have what pressing those buttons might look like if we were writing it in text form. So I have a graph, a representation of block coding using the arrows. So this is card 2. It's forward, right, forward. And you were writing this in a vertical column. So what that looks like if we were typing it out is, I say card 2, and begin thread, going down and indenting, say forward 1, down and indenting, right, down and indenting, forward 1, down, end thread. So the commands, our algorithm that have been sequenced are in this container of the begin thread and end thread. This is what the app with CodeJumper is going to start looking like. And the reason I'm talking about this so much is because when we get to CodeJumper, there will be a solid bridge from this to CodeJumper. So we're gonna, the whole process here, we're gonna build a maze, We're going to code the directions to get through that maze, and then Colby's going to run through that maze. And this is an image of a setup of one of the cards. I believe this is 11, card 11. And there's lots of twisty turny walls, 2 orange tunnels, but there's 2 paths. Colby could get to the cheese 2 different ways. The shorter way I wrote out as begin thread right, forward 1, left, forward 1, right, forward 1 in thread. So I think Diane has something to add here too.
Okay, not on this one, on the actions.
Oh,
Actions. Although I do want to say one thing real quick since you stopped there for a second. You notice that the mouse is facing to the left. It's always really interesting. The first time my students do this, they will always take the longer route because the mouse is facing left. They think they need to go forward, while the shorter route is for the mouse to initially turn and then move forward. So it's really interesting to see that after they do the long route, and I ask the kids to do the short route, the next time the mouse is facing a different direction, they actually problem solve first and find the shortest route. So there's all these little things that you can add into these cards and these little teachable moments. So be sure and take a few minutes when you're working with your kiddos to think outside the box.
Well, and that is a really good point actually about the perspective of the mouse.
Mm-hmm.
So we're looking at the mouse, and we can make a judgment of we're looking down at the map. We can look through both directions and figure out the shortest path. But the perspective of the mouse, he's facing to the left, but we're facing forward. And sometimes early on, the first time I did this with Tamaya, she struggled with that some too. We actually ended up turning the whole thing around or moving around to the other side of the table, so she was facing the same direction that he was facing. Just to start to understand, oh, when I say left for me, it's not necessarily left for him. Okay, so it's your turn, everybody. We have talked a lot. I have up on the screen an image of card 6. So this is both the card and the tactile graphic. And this is a more simple route. This is another piece where you can add some O&M. You can say, what would you call this kind of route? Some people might call this route a dog's leg or an S shape or a Z shaped route. He needs to go. Well, see, I want you to fill in the blank. If you can see the screen and you can fill it in, awesome. If you have it in front of you, it's card 6. If you don't, I will give you more details about this. Colby is in row, he's in row 4, column 1. He does not have a wall in front of him, but he does have a wall 1 square beyond that. The cheese is in row 3, column 3. So he needs to do he needs to go. I'm trying to describe it without giving it away. It's hard to do. Needs to make a Z-shaped route. Actually, no, it's the opposite of a Z-shaped route. I apologize. Needs to go up and over. But if anybody has some guesses of how they could go begin thread and then out talking about putting in the directions he needs to go, you can think about that. I will tell you he needs to go now. He needs to go forward, left, forward, right, forward. Okay. So there are two paths he could take. He could do what I just said. He could do the short route and go forward, left, forward, right, forward, and get to the cheese. But this one has an action. And the action is in row 2, column 1. But Colby is facing to the right. So there's 2 ways he could go. And if he gets to that action and you add in that piece of code by pressing the red round button on his back, he will do something random. He will flash his eyes. He'll do an extra squeak. He might move forward and back. We don't know. It's a random action. But it's fun and it's kind of exciting, though that makes the route longer. Is this where you?
Yeah, so I was going to add in there, originally, Leslie had told me, well, sometimes she puts the action card in there and she wants the student to go around that and not find the action card. And for me, when I have an older student or a student that's ready for a little bit more of a challenge, I make sure that they do use the action card, which again, Colby, if you program that in, Colby's going to do one of these random things. He might chirp or he might go forward and backwards and he'll end up the same place. But the kids love this extra little piece. And I really like the fact that it's a little bit more challenging for students because they have to figure out where to add that action in on their route and in on their code. So it's really kind of fun.
Yeah. Now, here is what those the 2 alternative paths would look like written out. And one is a little shorter than the other, but the one that has the action, it is written, you just add it in there. When you get to it, I placed one of the small coding cards on the mat to identify where it was for the pictures for the audience here. You don't have to do that. I just wanted to make that a visual clear point. So to get to the action, Colby would need to start by turning in place. He would need to go left, then forward 2. He'd hit that action. He would do something. Then he would need to turn right, go forward 2, and turn right again, and forward 1. So expanding on this, you can make a maze map of your house or your classroom. You can write your own code cards up, like Diane mentioned earlier. You can make your own tactile graphics. You can make up a maze with the with the picture maker, and then do it with Colby, or the other way around. You can find the fastest route, slowest route. You can avoid the actions, or you can target the actions. I should have put that on there. I just meant it as another challenge to problem solve through.
wanted to add one thing here, Leslie. One of the things that I like to do too, one of my goals with all of this is a listening goal. So the mouse starts and stops for each command, making it really easy for kids to identify how many steps that Colby's taken. The turns also have a really unique sound, so the students can follow along with what Colby's doing. So listening to the mouse traveling the route is more challenging than putting your hand on the mouse as he moves forward. I really like the listening skills as it teaches really basic sonification, that sounds have meaning. And that leads into the CodeQuest, where you use sonifications to follow the astronaut through his maze when you hit the play button or the run button. So I really liked adding that piece in there. I also like having the student follow the mouse and by listening, and have him put having the student put his finger and follow the code that he's written. So if the arrow codes or the move forward codes, then it can follow that down. So that tells me as a teacher, if the student understands what he's hearing and he can follow along. If you're not following the code, the student can also follow the tactile graphic of the maze and follow as the mouse moves along the tactile graphic. And again, that tells me as a teacher that my student really understands what's going on and has that whole big picture of what's happening.
Yeah, and that you can add a Braille reading element to that if you've written out the code on your Braille writer or in your CS journal. Maybe you're keeping a computer science journal to keep track of all the cool computer science related things you're doing. You can write that down or practice touch typing. You can expand on this in so many different ways. Another element that I think I forgot to mention earlier is with those small coding cards, when you can add the Braille and tactile stickers to them, you can also clip the corners. So you can give that extra orientation to those. Another thing that you can do with those, if you find them kind of slippy on the desk, is put Velcro on the back and put them on your picture maker board or your all-in-one board, or put a magnet on the back and put it on your all-in-one board. And then you can have your block coding. Okay, I believe we have another short little poll.
So I've launched that poll. So how are you doing? Are you feeling a little better about pursuing this with your students? Or great, I want to learn more? Or are you still confused?
And this might be another a good opportunity also. If you have a question, throw it in the chat. We have a couple of minutes left.
I'll give that poll one more minute. So what it tells me is we are at 80% great, want to learn more, and 20% I feel better about pursuing this with my students.
Oh, that is excellent. I'm really happy to hear that. So what's next? Well, now that you can have been exploring the world of coding with Colby and can read tactile graphics and can problem solve through mazes, you can join us next month, April 14th, for the third part of this series in Code Jumper. And in May 9th through the 13th is our National Coding Symposium. So look out for that. You can join us there. There's a lot to be had. And this is a picture of my current guide dog, Neil, following Colby around on the floor. He found him very interesting. He didn't try to eat him. He just followed him around and sniffed him. So next time we will dive into CodeJumper and how these two, CodeQuest and Code and Go Mouse, can bridge to CodeJumper, and how that can further you along on your road to code. I want to say thanks to Tamaya. She is my high school intern. And she's the star of the videos. So. If you don't know about the Hive, the APH Hive is free. It's a one-stop shop for ACVREP credit courses, self-paced, peer-reviewed. And if you are after your ACVREP credit for this webinar, that is also where you're going to go to download your certificate.
And Leslie, I'm going to move you forward to your resources slide.
Okay.
So that we can share all those resources out.
Yes, definitely do that. And this slideshow will be on the website for download as well. And I have tried to make it as accessible as I can. There's lots of resources here, several from Paths to Literacy. What do you do, Diane? Paths to Technology that Diane has written on this topic and on CodeQuest. And our Road to Code blog, as well as some other resources here.
And I would like to take the time to say thank you, Leslie, and thank you, Diane, for being a part of this webinar. It has been a great pleasure to have both of you present for us today.
Thank you very much. I love doing this, and please reach out for if you have questions, if you want to learn more, if you want to be pointed in towards more resources.